Have you ever looked up at the night sky and wondered what lies beyond the stars? Each one is a sun, burning billions of miles away. But if you could shrink down, past your skin, past your cells, past the atoms themselves, you'd find a world stranger than anything you've imagined. This is the quantum realm, a place where the rules of our everyday world no longer apply. It's not far away. It's right here, inside everything you see and touch. The solid ground beneath your feet, mostly empty space, held together by invisible forces. The light that lets you see, it behaves in ways that seem impossible. This is the universe's greatest magic trick, and we're all part of the audience. The journey into this world began over a century ago, when scientists tried to explain simple things, like the color of heated metal, and found their old theories didn't work. They had to write a new rule book, quantum physics. Quantum physics is our best description of how the universe works at its most fundamental level. It's a story of wonder, confusion, and breathtaking discovery. So, join me on this journey. You don't need complicated math, just curiosity. Let's peel back the curtain of reality and explore the building blocks of everything. We'll see particles in many places at once, and things that are both waves and particles. It might sound like science fiction, but it's the science of our reality. The quantum world is inside you, inside the air you breathe, inside the chair you're sitting on. Everything is governed by these hidden rules. The adventure is about to begin. Are you ready to see the universe in a new way? Let's step into the quantum universe. The story starts now. What is quantum physics? At its heart, it's the science of the tiniest building blocks of reality. The word quantum means how much, the smallest possible amount of anything. Imagine a ramp. You can stand anywhere, move smoothly up or down. That's classical physics, the physics of big things. But at the smallest scales, the universe is more like a staircase. You can only stand on the steps, not in between. Energy comes in these little packets, quanta. Quantum physics describes how these tiny packets of matter and energy behave. This was a revolutionary idea. The universe isn't smooth and continuous, but grainy and jumpy. Electrons and atoms can only exist at specific energy levels, like steps on a staircase. To move up, they must absorb a whole packet of energy. To move down, they must release one. No half steps allowed. This explains everything from why the sun shines to how lasers work. We don't notice the steps because they're incredibly tiny, but all big things are made of these quantum pieces. To truly understand the universe, we must understand its smallest parts. Quantum physics is our guide to this hidden reality. It's the ultimate instruction manual for the cosmos. The rules are strange, but they're the foundation of everything. Classical physics works for our everyday world, but quantum physics reveals the universe's true nature. The world is built from these tiny, indivisible steps. The quantum world is everywhere, shaping everything. And we're only just beginning to understand its language. Welcome to the world of quanta. One of the first surprises in the quantum world is wave-particle duality. Everything, light, electrons, can act like both a particle and a wave. Imagine throwing a pebble into a pond. You see ripples, waves spreading out. Now imagine throwing a grain of sand at a wall. It hits one spot like a particle. For centuries, scientists thought things had to be one or the other. Light was a wave, electrons were particles. Simple, right? But the universe had other plans. The double-slit experiment changed everything. Scientists fired electrons at a screen with two slits. If electrons were just particles, you'd see two lines. Instead, they saw an interference pattern. Many lines, like waves overlapping. The electrons seemed to pass through both slits at once, interfering with itself. But if you watch to see which slit it goes through, the pattern changes. The wave behavior vanishes. You get just two lines, like particles. It's as if the universe knows you're watching. The act of measuring forces it to choose, wave or particle. This is the mystery at the heart of quantum mechanics. Reality depends on how and if we look. The building blocks of our world are both waves and particles, depending on the question we ask. The rules are stranger than we ever imagined. The quantum world defies our common sense, and this is just the beginning. The double-slit experiment reveals something profound. Quantum objects aren't just particles or waves. They're both and neither. Before we measure, an electron exists as a wave of probability, describing all the places it could be. Only when we interact with it does this wave collapse into a single definite reality. In our everyday world, objects have definite positions. But in the quantum realm, the observer is part of the experiment. Looking isn't passive. It helps create reality. Before we look, the electron is a cloud of potential. The moment we look, It snaps into focus at one point. Where it appears is a matter of probability, not certainty. This means the universe isn't deterministic at its core. In classical physics, knowing everything lets you predict the future perfectly. Quantum mechanics introduces pure chance. We can calculate the odds, but never know for sure. Einstein disliked this, but experiments prove it's true. The interference pattern is proof. A single electron behaves as if it travels all possible paths at once. This is the idea of superposition, existing in multiple states at the same time. It's a cornerstone of the quantum world. Reality is built from possibilities, not certainties. The act of measurement shapes what is real. The quantum world is a place of endless potential, and it leads us to even stranger ideas. Let's explore superposition. Superposition means a quantum object can be in multiple states at once. It's not just in state A or B, it's in a combination of both, simultaneously. Until we measure it, a particle exists in a haze of all its possible outcomes. Imagine spinning a coin. While it's in the air, it's both heads and tails. Only when it lands do we see one result. An electron spin can be up or down, but before we measure, it's both at once. This is the idea behind Schrödinger's cat, a cat in a box, both dead and alive until we look. Of course, we never see cats in both states, but for atoms and electrons, superposition is real. When we measure, the superposition collapses into one outcome. For single particles, this is everyday reality. We can now control and use superposition to build new technologies. Superposition is not a fantasy. It's the foundation of quantum science. It's what makes quantum computers possible. The quantum world is a place where possibilities coexist. Measurement turns possibility into reality. This is the magic at the heart of quantum mechanics, and it's changing our world. In the quantum world, outcomes are decided by probability, not certainty. The wave associated with a particle is a wave of probability. Where it's high, you're likely to find the particle. But you can never be 100% sure where it will land. Unlike a classical coin toss, where randomness is just ignorance, quantum randomness is real. It's woven into the fabric of reality. The wave function describes all possible outcomes and their probabilities. When we measure, the wave function collapses, and one outcome is chosen at random. Repeat the experiment 1,000,000 times, and the results match the predicted probabilities, but you can never predict a single event. This isn't a flaw, it's the theory itself. Quantum probability powers lasers, transistors, and nuclear energy. Our technology depends on manipulating these odds. The universe is not a perfect clockwork machine. Quantum randomness is the engine of change and innovation. It's what makes our world so rich and unpredictable. Quantum physics isn't just for labs. It's in your pocket right now. Your smartphone, computer, and the internet all exist because we've learned to master the quantum world. Computer chips use billions of transistors, controlling electrons with quantum rules. Every photo you save, every message you send, is a dance of quantum events. Lasers, another quantum invention, power everything from Blu-ray players to surgery. Even the sun is a quantum engine, powered by quantum tunneling, particles passing through barriers they shouldn't cross. Without quantum mechanics, our modern world wouldn't exist. The quantum world is the foundation of our technology. It's not distant or abstract. It's the reason you can watch this video. Every time you stream, swipe, or search, you're using quantum physics. The invisible rules of the quantum world shape our daily lives. The future will be even more quantum-powered. The magic of the quantum realm is everywhere. It's the engine of our existence. We're entering a new era, a second quantum revolution. Now, we're learning to control individual quantum objects. The most exciting frontier? Quantum computers. Unlike regular computers, which use bits, zeros or ones, quantum computers use qubits. Thanks to superposition, a qubit can be 0, 1, or both at once. This lets quantum computers explore vast possibilities simultaneously. With just a few hundred qubits, they could solve problems impossible for today's supercomputers. We could design new medicines, materials, and artificial intelligence. Quantum computers could break current codes, so we're inventing quantum cryptography. Building these machines is a huge challenge. Quantum states are fragile and easily disturbed. Scientists work in ultra-cold, ultra-clean labs to protect them, but progress is rapid. We're on the brink of a new technological era powered by quantum understanding. The future is being built one qubit at a time. The quantum revolution is just beginning. We've journeyed from the stars to the heart of the atom. We've seen that reality is built on probability and possibility. Particles can be in many places at once. Observation changes what we see. The quantum world isn't just a curiosity. It's the engine of our technology and the key to our future. The laws that govern stars also govern the atoms in your hand. We're deeply connected to the cosmos through quantum rules. There's still so much we don't understand. How does probability become certainty? How does quantum physics fit with gravity? These are the puzzles for the next generation of scientists. And maybe you. The greatest discoveries may still lie ahead, hidden in the quantum foam. So keep asking questions. Stay curious. You don't need to be a physicist to appreciate the universe's beauty and mystery. The quantum world is your world. The adventure is just beginning.